Hi, welcome to my video on review 2 of coordinate geometry. And this review deals with the videos numbers 8 to 12. And again, as in most of my reviews, you can treat it as a quiz where you give yourself marks for each question. And this quiz is marked at a 24. So we have one of 4 pages is the first one. We have 3 more to do. And as you do each question, give yourself a mark, total up the questions on each page, and then put it over 24 and divide 24 into this numerator. Get a decimal, move a decimal 2 places to the right to get a percent. So here we go. This is the last video on this coordinate geometry unit. Number 1, P is 2, -1, Q is 3, 2, R is 4, 5. Prove P, Q, R are collinear. Collinear points are points that lie on the same line, and if points lie on the same line, then between any 2 points I should have the same slope. And again, to represent that, let's draw a diagram. Again, we should know that's the x and that's the y-axis. So the point P is 2, -1, right there. Q is 3, 2. So let's say it's there. So that's Q. And R is 4, 5. So R, let's say R is right there approximately. So you can see that the 3 points are, we join them up, they're on the same line. And to show that, we will do the slope of PR, the slope of PQ, and we'll do the slope of QR, as long as you take 1 point twice. So P is 2, -1, and Q is 3, 2. So this is x1, y1, x2, y2. So the slope is y2 minus y1 over x2 minus x1. So y2 is 2, y1 is -1, x2 is 3, and x1 is 2. Double negative is a positive. So that gives you 3 over 1, or 3. And now we'll do the slope of QR. So Q is 3, 2. R is 4, 5. And y2 minus y1, so it's 5 minus 2 and 4 minus 3. That's 3 over 1, which is 3. So the slope of PQ is equal to the slope of QR, which is equal to 3. And since slopes are equal, the points are collinear. And if you picked up this slope, a mark. If you picked up this slope, a mark. If you made this statement, you get a mark, so that's 3 total. Number 2, don't forget, pause the video and work this out first if you wish. Verify that H24 and K15 lie on the circle with the center O as -2, 1. Again, let's draw a diagram to illustrate this. H is 2, 4, right here. K is 1, 5, which is there. And O is -2, 1. So that's O. H is 2, 4, and K is 1, 5. So there is a circle that we draw, and again, notice that if these points lie on a circle, so there is the circle, something like that, just a rough sketch. So if these 2 points lie on the circle, that means OK and OH are radii. So that means if they're radii, the radii are OK and OH. That means OK is equal to OH because the radii of a circle are equal. So let's do O is negative 2, 1, and we'll do H, which is 2, 4. Let's use the distance formula and get the length of OH, which is a radius. So the distance formula is x2 minus x1, add on y2 minus y1. This is x1, y1, x2, y2. And so x2 is 2 minus negative 2. y2 is 4 minus y1, which is 1, squared. Double negative is a positive. This is square root of. That's 2 plus 2 is 4 squared. And that's 3 squared. We worked out the brackets first by PEMDAS. Now we'll square next. 16, 9 gives us 25. So OH is 5. So now let's do O, which is negative 2, 1. And we'll do K, which is 1, 5. And again, the distance of OK is the distance formula. And there's the distance formula. So this is x1, y1, x2, y2. So there it is there. So x2 is 1 minus negative 2 squared. y2 is 5 minus y1 squared. And again, we have a double negative, so we have a positive, so that's 3 squared. 5 minus 1 is 4, being squared. 3 squared is 9, 3 times 3. 4 squared is 16, 4 times 4. That's 25, and that gives us the distance is 5. So notice that OK is equal to OH, which is equal to 5. So since they must lie on the circle because the radii are equal, the radii of a circle are equal. That means that the points H and K lie on the circle because the radii are equal. The distances are equal. And we have to give some marks. So for this one here, we get 2 marks. For this one, we get 2 marks. And we made the statement, which we have to do. We get an extra mark, so 5 marks altogether. Total of 8 for that page. And we have another one to do. Again, don't forget to pause the video. Show that the triangle HIJ is a right triangle if H is negative 3, 6, I is 2, 10, J is 6, 5. And again, like before, let's draw a diagram. And it says that H is negative 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. I always draw a picture because then if you have a right triangle, well, a right triangle got a right angle. That means the right angle got perpendicular lines. By drawing the diagram, you see which ones are going to be perpendicular. And that's the two you do without doing all three, because if you didn't know where the right angle was, you would have to do the slope of all three. So I is 210. That's 6, 7, 8. 10 is, I'm gone way up here, but that's okay. And we got 6, 5 right here. So we have H, we have I, which is right here, and we have J. So if I form a triangle like this, you can see that the right angle is not here. The right angle must be right here. So that means that I will do the slope of HI, and then I'll do the slope of IJ, and as a result, I should have, if that's the right angle, I should have perpendicular lines here, yes, and that means I should have these negative reciprocal to each other. So H is negative 3/6, and I is 210. So we're doing the slope. Slope is y2 minus y1, x2 minus x1. Double negative is a positive, so that's 4/5. And we have I, which is 210, and we have J, which is 6/5. So we do the slope as y2 is 5 minus y1 is 10, all over 6, which is x2 minus x1. So that's negative 5/4. And note the slopes. The slopes are the negative reciprocals of each other. Therefore, that means that HI is perpendicular to IJ, and that means that angle I is a right angle, or 90 degrees, whatever way you want to say it, 90 degrees, and that because it's a right angle, that means that the triangle HIJ is a right triangle. And the reason for that is definition of a right triangle. Because a right triangle got a right angle. A right triangle has 90-degree angle. And there's 6 marks here. So if you got that slope, you give yourself a mark. If you got that slope, you give yourself a mark. If you mention the negative reciprocals, you got a mark, perpendicular, 90-degree angle, right triangle. So there's the 6 marks. 1, 2, 3, 4, 5, 6. Total 6 on that page. And we have one more question to summarize or to bring down a review on these videos. And this is a really good question. It has integrated the ideas of tangents, perpendiculars, circles, and equation of lines. Here we go. The center of a circle is O, which is 1, 2. The point A, which is 4, -2, and B, which is -3, -1, lie on the circumference. Find a point of intersection of the tangents to the circle at A and B. Well, again, like before, let's draw a diagram. And we have O is the center. O is 1, 2. There's O. A is 4, -2. There's A. Right there. B is -3 for X, and Y is -1. So there's B. and it says that these 2 points A and B lie on the circumference, and find the point of intersection of the tangents. So this is O as the center. So this is a radius right here, and this is the radius right here. So the circle is out through here like this. So these O is the center. These are the points on the circumference, and find the point of intersection of the tangents to the circle. So if the tangent has to go through this point, so here's the tangent at A, and here's the tangent at B, so how are we going to, well, it looks like this is the point of intersection here, but that's approximate. So what we got to do is get the equation of both tangents and solve them. So here we go. So let's the equation of, let's get this, let's do this tangent first at O. So let's have O, which is 1, 2, and let's have A, which is 4, negative 2. So let's get the slope of this radius right here. So the slope of OA is y2 minus y1 over x2 minus x1. So that's 4, negative 2. So that's negative 2 minus 2. So that's a negative 4 over 3. So that means that the slope of the radius, remember, a tangent and a radius makes a 90-degree angle. So if the slope of the radius is negative 4 over 3, then the slope of the tangent is the negative reciprocal. So it's 3 over 4. That's a negative, so we make it positive and flip the fraction. And that is at A, so let's put A to be 4, negative 2. So the equation of the line, y equals mx plus b, A is that's x and that's y. So y is negative 2, m is 3 over 4, x is 4 plus b. Negative 2, the 4's cancel. You get 3 plus b. So negative 2 minus 3 equals b. So b becomes negative 5. So the equation of the tangent, y equals mx plus b. The slope of the tangent is 3/4. And the y-intercept is negative 5. So that's the equation of the tangent at A. So now let's go with O, which is 1, 2, and we'll go with B. And B is negative 3, negative 1. So let's get the equation of this tangent. Okay, here we go. So again, we'll get the slope of OB. And the slope of OB is y2 minus y1, and x2, negative 3, minus x1. So that's negative 3 over negative 4. Negative over negative is a positive. So the slope is 3/4, and is going through B, and B is negative 3, negative 1. But that's the slope of the radius. So the slope of the tangent is the negative reciprocal. So that's a positive, we make it negative, so it's 4 over 3. And is going through B. So here's the equation. So this is x and y. Y is negative 1. Slope is negative 4 over 3. X is negative 3. B negative 1, negative times negative positive, 3's cancel, so you get 4 plus b. Negative 1 minus 4 equals b. B is negative 5. So the equation, slope, y equals mx plus b, slope of the tangent is a negative 4 over 3x, and the y-intercept is negative 5. So without going any further, you can see that both of them both have a y-intercept of negative 5. So that means the point, if you've got a y-intercept of negative 5, then the x-coordinate is 0. So right away, that's done. So that's the point of intersection of the two. Or, if you want, you can take the two equations. If you didn't notice that, you could take 3 over 4 x minus 5 and a negative 4 over 3 times x minus 5, and both of these are equal to y, so they're equal to each other. So I'm going to multiply by 12, which is the LCD. So 4 into 12 goes 3. 3 times 3 is 9. 12 times 5 is negative 60. 3 into 12 goes 4. 4 times negative 4 is negative 16x. 12 times negative 5 is negative 60. So 9x plus 16x is equal to negative 60 plus 60. 25x is equal to 0. Divide by 25, x is 0. And if you can see it, just go over here. If you take y equals 3/4 x minus 5, and you put x equals 0 in, y is equal to 0 minus 5. So y equals minus 5, x is 0. So again, if you solved it, you would have x is 0, y is negative 5. But if you notice that both got the y-intercept at negative 5, and you say, well, the point is 0, negative 5, you got full marks. If you solved it, you still get the same, but you just did more work. And so there's 10 marks here. So the slope is 1 mark, negative reciprocal is a mark, picking up the negative 5 is a mark, and writing the equation. 4 marks here, and it's the same 4 marks over here. 1, 2, 3, 4, 8 marks altogether. If you did it this way, there's 2 marks here. If you solved it out and got x is 0, negative 5, and did the point, there's still 2 marks. So 10 marks altogether. So that's a good question on, again, find the equation of the, find the equation of the tangents and then solving it with a system of equations. Add up your pages and again put it over 24 and convert it to percent. And that brings us to the end of this video, brings us to the end of this unit actually, and hopefully you enjoyed the unit on coordinate geometry and you learned all the concepts involved with dealing with midpoints and slopes and equations of lines, etc., etc., etc. And if you like my video, click on the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And as the content is on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.